So a linear equation is an equation that just has one variable. It can be any letter. It doesn't have to be x or y. And then solution is the answer that makes the equation true. So to solve equations, I use inverse operations. I'm going to start by drawing a line down the middle. And then I want to do the opposite of whatever is next to x. So if I take a look at number 1, I have x minus 3. So the opposite of subtracting 3 is to add 3 to both sides. So I go ahead and add 3 to both sides. On the left side, the 3's will cancel out because they're opposites. And I'm left with x. And on the right side, I have 5 plus 3, which gives me 8. So my answer here is x equals 8. Okay. I'm going to do the same thing on number 2. Even though I have decimals, it's not going to change a thing. It's just the same thing. So I'm going to draw a line down the middle. And I'm going to start off by subtracting 2.8 on both sides. I will use a calculator for this one. So I am going to do 0.9 minus 2.8 gives me, on the left side, gives me negative 1.9. On the right side, it cancels out. I'm left with y. So my answer here is just y equals negative 1.9. Moving along, doing the same thing over here on number 3, except this time I have a negative 5, or the whole fraction is negative, and I have a 5 on the bottom. Fractions are the same thing as division. The opposite of dividing is multiplying. So I'm going to multiply both sides by negative 5. On the left side, these cancel out. I'm left over with n. Negative 3 times negative 5 gives me a positive 15. So I get n equals 15 for number 3. Number 4, pi is just a number. It's not a variable. It's kind of confusing because it looks like it could be a variable. But pi always means 3.14 whenever I see it. So it counts as a number. So on these two, or on this one, I'm going to divide pi on both sides. On the left side, it cancels out. And crazily enough, on the right side, it cancels out as well. So I have x on the left side and negative 2 on the right side. So my answer here is x equals negative 2. Okay. Moving on, I have number 5. It wants me to write an equation to solve it. So it tells me that Whitney has $450 in the bank account, and she saves $150 every week. It wants me to label my variable and then decide how many weeks she's saving for. So I'm going to start off by labeling my variable. X is my number of weeks. Okay. Then I'm going to go ahead and I'm going to have 450, because that's how much she starts off with. And I know she saved 150 every week because it's happening on a weekly basis. It's multiplication. And then I'm going to go ahead to solve this. I'm going to divide by 150 on both sides. Then I get, use the calculator, 450 divided by 150 gives me 3. So I get x equals 3. So she'll say for 3 weeks. Okay. Now what I want you to do is I want you to take a few minutes and solve these, let me make this a little straighter. Solve these 5 practice problems on your own. Pause the video, take a few minutes to work on it, because I am going to just move on ahead to the next section. Okay. Moving on, I'm solving multi-step equations. So this is kind of like what I was doing in the first one, except what I'm doing now is I'm still getting the variable by itself, but now it's going to take more than one step. So I start off by drawing my line. On number 1, I have 2.5x minus 13. What I want to do is I'm going to start off by adding 13 to both sides. Okay. So on the left side, I get 2.5x, and the negative 13 plus 13 cancels out. On the right side, I have 2 plus 13, which is 15. I still need to get x alone, so I'm going to divide by 2.5 on both sides. Oh, and I forgot to say it, but when I am solving multi-step equations, I solve them in opposite PEMDAS order. So normally I multiply and divide, and then add and subtract. When I'm solving, I add and subtract first, and then multiply or divide. Okay, so on the left side, the 2.5s cancel out. I have x. On the right side, I want to do 15 divided by 2.5 gives me 6. So my answer for number 1 is x equals 6. I'm going to do the same thing for number 2. I'm going to start off by drawing my line down the middle. I have divide and subtract, so I'm going to start by doing the opposite of subtracting, which is adding. So I still have f over 9, 4, I can read. And then on the right side, I have negative 9 plus 5, which gives me negative 4. To get rid of my fraction, fractions are division, so opposite of dividing is multiplying. I'm going to multiply both sides by 4. So then I get f on the left and negative 16 on the right. So my answer is f equals negative 16. Okay. Same thing for 3. I'm going to start off by subtracting 4 on both sides. I get 3x on the left, and on the right I get 15. Then I want to divide both sides by 3. I get x on the left. 15 divided by 3 is, I wanted to cross this out, is 5. So my answer for number 3 is x equals 5. Number 4 is a little bit trickier. Notice how everything's being divided by the 4. That means that's the first thing I have to get rid of. So I'm going to start off by multiplying both sides by 4. On the left side, the 4's cancel out, and I'm left with k plus 1. On the right side, I have 3 times 4. It gives me 12. Then I'm going to subtract 1 on both sides. I get k on the left, 11 on the right. So my answer for number 4 is k equals 11. Now what I want you guys to go do is, again, pause the video, take a few minutes to work on these 4 practice problems, and then I'm going to move ahead to the next notes, which are going to be day 2. Okay, the next thing I might have to do is combine like terms in order to solve. What I want to do here is I am going to see things that have in common. So I'm still going to draw my line on the side, but before I even start moving things over, I'm going to just see what I can put together. Can't do anything on the left side, so it just stays negative 12. Over here on the right side, I have a positive 9x and negative 6x. 9 minus 6 is going to give me 3x, and then that 15 is just going to stay right where it is for now. Then I want to go ahead and solve this, so I am going to start by doing the opposite of adding 15, which is subtracting. So I subtract 15 on both sides. I get negative 27 on the left. 3x stays the same, but now my 15s will cancel out. And I want to go ahead and divide 3 on both sides. Negative 27 divided by 3 is negative 9. 3x divided by 3, the 3's cancel out, so I'm left with x. And the final answer here is x equals negative 9. Same thing on number 2. I'm going to start off by combining like terms. I have a 12x and a 2x, so 12 plus 2 is 14. And then I have an x. The plus 4 stays for now, and same thing with the 39. Then I want to go ahead and move the 4 over, so the opposite of adding is subtracting. I have the 14x still left over, but the 4's cancel out. 39 minus 4 gives me 35. I'm going to go ahead and divide both sides by 14. On the left side, they cancel out nicely, but on the right side, 35 and 14 does not divide out nicely. But what I can do is both of them can be divided by 7. So 35 divided by 7 is 5. 14 divided by 7 is 2. And then I still have the x on the left. So my answer here is x equals 5 halves. Okay. Moving on, something else I can do is use the distributive property to solve the equation. So what that means is I'm going to take the number up front and distribute it in. So 2 times 1 is 2. 2 times negative x is negative 2x, and the 3 from before is still there. And the negative 8 on the left side. Then I'm going to go ahead and combine like terms. I have 2 and 3, which is 5. The negative 2x stays, and same with the negative 8. Then I'm going to go ahead and subtract 5 on both sides because it was positive. So I have negative 2x. Negative 8 plus negative 5 gives me negative 13. Then I divide both sides by negative 2. The negative 2's on the left cancel out. On the right side, the only thing that I can change is turn both those negatives into a positive. So now I have x equals 13 over 2. Same thing on number 4. I'm going to start by drawing my line. 33 stays where it is. 12r stays where it is. I'm distributing the negative 3, and I need to remember that the sign goes with the number. Negative 3 times 9 is negative 27. Negative 3 times negative r is going to turn into positive 3r. Then I'm going to go ahead and, just like earlier when I was combining like terms, I'm going to combine them here. So I have 12r and 3r, which turns into 15r. The 33 on the left stays where it is, and the negative 27 on the right stays where it is. And I want to move the number to the other side, so I'm going to add 27 to both sides. 33 plus 27 is 50. 15r stays where it is, the 27's cancel out. Then I'm going to go ahead and, dang it, I cannot add. This gave me 60. Okay, then I'm going to go ahead and divide by 15 on both sides. 60 divided by 15 is 4. 15's cancel out on the right. And I have r. So my final answer here is r equals 4. Okay, I'm going to show you the practice problems in the back really quick. So here are the 4 practice problems. Take a few minutes, pause, work on the problems, and then I'm going to move ahead on to 1.3. So now I'm solving equations still. But now I have variables on both sides of the equation. What I'm going to do here, just like before, I'm going to go ahead, draw that line down the middle, and then I'm going to move variables to the other side. So on number 1, I'm going to start by adding 4x to both sides. I'm left with 10 on the left. The 4x's cancel out. Negative 9 plus 4 is negative 5x. Then I want to, even though it's on the wrong side of the equation, I'm still going to work with it because it doesn't actually matter what size of the equation my variable is on. I'm going to divide by negative 5 on both sides. Negative 2 on the left. On the right, the negative 5's cancel out, and I have x, so my answer is x equals negative 2. Moving on to, that is not a straight line. Moving on to number 2, I am going to start by moving I can actually move the variable or the number to the other side. I am going to just move 3k. I could have moved 8k, I could have moved 45, I could have moved 25. I'm just picking 3k because it's the smallest number. So on the left side, the 3k's cancel out. I have 45 on the left. 8 minus 3 is 5k. On the I have the 25, which had nothing happen to it. I'm going to then move the 25 over to the other side, so I'm going to start 25 on both sides. 40 minus 25, 45 minus 25 is just 20. I have the 5k because nothing changed with that, and the 25's cancel out. Then moving on, I divide by 5 on both sides. I get 4 on the left, k on the right. My answer is k equals 4. Here are 2 practice problems for you to take a moment, pause, solve, and then I will continue on the 1.3a2. So just like on 1.2, the second part was me distributing. I need to distribute on both sides of the equation before I can go ahead and solve. So what I'm going to do is I'm going to distribute 3 times 3x is 9x, 3 times negative 4 is negative 12. Then over here on the right side, I have this fraction. Remember, fractions are nothing to be scared of. This 1/4 actually means divide by 4. Means divide by 4. So when I go and distribute this, I'm actually going to divide those numbers by 4. So I have 32 that needs to be divided by 4. That turns into 8. Then I have 56 that needs to be divided by 4. That turns into 14. Okay. Then I can go ahead and draw my line. and solve like before. I'm going to start by moving the 8x because that is the smallest number, but like I said earlier, I can move anything I want. 9x minus 8x is going to give me x. The negative 12 stays where it is. The 8x's cancel out, and I have 14 on the right. Then I want to go ahead and add 12 to both sides. I get x on the left, the 12's cancel out, and then I get 26 on the right. So my answer for number 1 is x equals 26. Okay. Same thing as before, I'm going to distribute the number out front. I have 8 times 2r, which gives me 16r. 8 times negative 3, which gives me negative 24. Notice that the second r is not in parentheses. This means I do not distribute that 8 to it, so it's just going to say negative r. And then on the second side, I'm going to go ahead and distribute that 3. 3 times 3r is 9r. 3 times 2 is 6. Now I can go ahead and draw my line down the middle and combine like terms. So I have 16r and negative r. So 16 minus 1 is 15. 15r. Then I have minus 24. On the right side, I have 9r plus 6. Then I'm going to go ahead and I'm going to start off removing my 9r. So I subtract 9r on both sides. 15 minus 9 is 6r. Still have the negative 24. The 9r's cancel out, and I have 6 on the right. And I'm going to go ahead and add 24 to both sides. I have 6r on the left. 6 plus 24 is 34. Then I'm going to go ahead and divide by 6 on both the left and right. On the left side, the 6 cancel out. I have r. On the right side, I have 30 divided by 6, which gives me 5. So my answer here is r equals 1. Then I have 2 practice problems for you on this. Take a moment to pause, solve, and then move on to 1.4 when you're ready. 1.4 is moving on to absolute value equations. What happens with an absolute value equation is it actually just tells me the distance away from 0. So one thing to consider is the absolute value of negative 4 is 4. It just gets rid of the sign. So when I'm asked to solve the absolute value functions, I'm looking for a positive and a negative answer. So I will have, for the most part, always 2 answers for absolute values. So number 1 is going to have 4 and negative 4 as my answers. On number 2, I actually have no solution because absolute values are always turning things to positive. I can't work backwards. If it's telling me an absolute value equals a negative, that is not something that can happen, so I can't. So that's what I guessed. Moving on. Now I have ones that are just more than the absolute value. So what I'm going to do is make 2 equations to solve one positive and one negative. So again, I'm going to start off. I have x minus 4 equals 6. That's normal. I just got rid of the absolute value symbols. And then I have a second equation I'm going to write. X minus 4 equals negative 6. So what I'm going to do now is I'm going to go ahead and solve both of these equations. I'm going to add 4 to both sides on my first one. I get x. The 4's cancel out. 6 plus 4 is 10. So I have one answer. X equals 10. I'm going to do the same thing on the second one. I'm going to add 4 to both sides. I get x on the left because my 4's cancel out. Negative 6 plus 4 gives me negative 2. So I have another answer of x equals negative 2. Taking a look at number 4, I have an absolute value equals a negative. If it already equals a negative, I cannot split this up into two equations, because remember earlier I told you absolute values can't equal a negative number. Off the screen yet again. So my answer for number 4 is going to be no solution. I'm going to quickly show you the ones I want you to solve on the back. There's 4 practice problems. Take a moment, pause, solve, and then move on to day 2 with me. So here is day 2. When I am working with absolute values, I always want to start off by getting the absolute value by itself. So if I take a look at number 1, I can see that it is not by itself. It's got this negative 10 on the same side of the equation. I always want it to be absolute value on one side and then number on the other. And then from there, I can go ahead and split it into two equations. So get the absolute. So, and then the second step is split into two equations. So starting off at number 1, I'm going to add 10 to both sides. I still have the absolute value of 3x plus 9, but now, instead of having 4 on the right side, I have 14. I am going to split it into two equations now. I have 3x plus 9 equals 14, and then my second equation is going to be 3x plus 9 equals negative 14. I'm going to go ahead and draw my line down the middle. I'm going to start off by subtracting 9 on both sides. I get 3x on the left because the 9's cancel out. 14 minus 9 is 5. I will go ahead and divide both sides by 3. Left side, the 3's cancel out. I'm left with x. Right side, I cannot do anything with that, so it stays 5/3. So my first answer is x equals 5/3. I'm going to do the same thing for my second equation. I'm going to go ahead and draw my line down the middle. Subtract 9 on both sides. I get 3x on the left. The 9's cancel out. This time I have 14 minus 9, which gives me negative 23. Then I'm going to divide 3 on both sides. Cancels out on the left. Cannot do anything on the right, so I just have x equals negative 23/3. So those are my two answers. Number 2, I'm going to start by adding 3 to both sides. I have negative 2 absolute value 5x minus 1 equals negative 8. Then I'm going to go ahead and divide by negative 2 on both sides. I have absolute value 5x minus 1 equals a negative divided by a negative turns positive, so I have 4. Now I can go ahead and split this up into two equations. I have 5x minus 1 equals 4, and then 5x minus 1 equals negative 4. Drawing my line down the first one, that is off the screen. I am going to add 1 to both sides. I have 5x on the left, my 1's cancel out. 4 plus 1 is 5, so I'm going to go ahead and divide 5 on both sides. Left side, they cancel out. On the right side, they do not cancel out because the number divided by itself is always 1. So I have x equals 1 for my first solution. Then on the second one, I'm going to go ahead and add 1 on both sides. I have 5x on the left and negative 3 on the right. Divide by 5 on both sides. I have x and negative 3/5 because I can't simplify that. So I am going to take a few minutes. I mean, not take a few minutes. You're going to take a few minutes. Pause this and solve the 2 at the bottom of the screen. And then when you're ready, join me on 1.5. 1.5 is solving literal equations. A literal equation is just an equation with two or more variables. And basically it's just a formula, and I'm rearranging it to get whatever letter I want by itself. So we want to get the specified letter by itself. So number 1, it wants me to solve for C. I'm going to start by drawing my line down the middle. Everything but C needs to move over. So R is positive, so I'm going to subtract R on both sides. P and R are not the same letter, so I'm going to have P minus R. On the right side, the R's will cancel out, and I have a negative C. Both of these are going to divide by -1 to make that C positive. So I'm going to have negative P plus R. And then on the right side, the C turns positive. So my answer here is C equals negative P plus R. Number 2 is solving for R. Because all 3 letters are written next to each other, this means they're being multiplied. So I am going to actually start off by dividing by P and T. So I have I divided by P and T on the left, and just R on the right. So rewriting this is R equals I divided by P times T. That's all I need to do. Solving these equations just means getting the letter by itself. It doesn't actually mean getting a number answer. Take a few minutes, solve the 2 on the bottom, pause it, and then when you're ready, play to continue on to the last set of notes for chapter 1. Okay? So, sometimes when I'm rewriting equations, literal equations, I need to either factor out a number or, no, I need to factor out a letter. This is what happens when I have a letter that appears twice. So I'll show you what that means in a second. Actually happens in number 2, not 1. So number 1 wants me to solve for y. I'm just going to move the whole quantity over. So over here it says positive 3y plus 4x equals 9. So I'm just going to subtract 4x on both sides. I get 3y on the left, and then negative 4x plus 9, because none of those things can combine. Then I'm going to go ahead and divide by 3 on everything. On the left side, the 3's just cancel out, so I have y. On the right side, I have negative 4/3 x. And then 9 can divide by 3, it turns to 3. So my answer here is going to turn into y equals negative 4/3 x plus 3. Number 2, when I want to solve for x, notice it's appearing in both these pieces. I'm going to start by dividing each of those by x. So I'm going to leave it y on the left. I'm going to write what I'm dividing by on the outside. So if I take a look at this first piece, 3x divided by x is 3. And then on the second piece, 5xz divided by x, the x's just cancel out, so I'm just left with 5z. Now notice, I have x times a quantity. I can undo multiplication by dividing, so I am going to divide both sides by this 3 plus 5z. 5z, not x. On the on the right side, this whole thing just cancels out, and I am left with x equals y divided by 3 plus 5z. Okay. Here are the last few practice problems you need to solve.